In this video, we are going to factor polynomials, and I have two examples here. The first one I want you to notice that there's three terms. Here's the first term, here's the second term, and the third term. So there are three terms. Now what we do when we approach these problems is we try and see if the terms have common things in them, or common factors, or things that they each have. And I notice very quickly that each one of these terms have an x. I have an x cubed, an x squared, and x. That right there tells me that I can factor out an x. Now, do I factor out x cubed or x squared or x? You factor out the least powered x, which in this case is x. So you factor out the x, you have your parentheses, and now you think to yourself, x times what will give me that first term? Well, x times x squared will give me x cubed. And that's how you get your first term inside the parentheses. Next thing you do, this minus sign, you bring it down, minus. Now for your second term, you think to yourself, x times what will give you 2x squared? Well, I definitely have to multiply by a 2. So far, x times 2 will give me 2x. I need 2x squared, so 2x times x will give me 2x squared. I'm done with the second term, and now you bring down this minus sign. And now x times what will give me 3x times 3. And that's how you factor when you have something that's in common in all the terms. Now, we're not done yet. We're not done yet. Remember that we always need to look at what's left in the parentheses to make sure that I can that if I need to factor further, I do that before I say that I'm done. Okay? So looking at this trinomial inside the parentheses, I can see that I can factor that trinomial further. This piece. This x, just bring it down. This piece, I can see that I can do x and x, and then I look at this number and think about the factors of 3. And I think about those factors, adding them together or subtracting them together and getting 2. And I know that will happen with these factors. The factors here are 1 and 3. 1 and 3, if I subtract them, I will get 2. So I know that I need to use 3 and 1. Now I have to decide on the sign. If this is negative 3, then either 3 or 1 have to be negative, so that when I multiply them using FOIL, I get back negative 3. I also notice that my 2 here needs to be negative, so that tells me that when I subtract 3 from 1, I need to get negative 2. And the only way that happens is if 3 is negative and 1 is positive. And that's your final answer. You have factored the polynomial, and when we say factoring, what we mean is we take the original polynomial and we write it as factors. So this is one factor, this is the other factor, and here's the other factor. 3 factors. Okay? Now, that means that if I multiply this factor times that factor times this factor, I will get back the original function. For example number 2, I look at the 3 terms, and all 3 of them have something in common, an x, just like in the first example. But I also notice that the numbers have common factors. And in this case, they all share a factor of 2. That means that I can write 2 times 18. I can write 18 as 2 times 9. I can write 60 as 2 times 30. And I can write 50 as 2 times 25. So notice all of them have a common factor of 2. So I'm going to pull that factor out, and I'm also going to pull out an x. Okay, so in this case, I have a common number and a common variable. And this is how it should look. I'm going to pull out a 2. I'm going to pull out an x and start my parentheses. Inside my parentheses, originally I have 18x cubed. So 2x times what will give me 18x cubed? Well, 2 times 9 gives me 18, and x times x squared gives me x cubed. And there is my first term. If I multiply this times that, I will get back that first term. This minus sign, just bring it down. Now we're going to work with 60x cubed. 2x times what will give me 60x cubed? Well, 2 times 30 will give me 60. And x times what will give me x cubed, x squared? X. Again, if you multiply 2x times 30x, you will get 60x squared. Then I bring down this plus sign. And now 2x times what will give you 50x? Well, 2 times 25 is 50. And x times 1 will give you x. So I don't need to multiply here by x. And there you have it. And again, just as in the previous example, make sure that this trinomial you can maybe factor further. So I'm going to try. And for this one, since I have a number here in front of x squared, I have 2 options because I can break 9 up into 3x times 3x, which will give me the 9x squared. The other option is I can break it up as 9x times x. So you have 2 options, and we have to try both and see which one will work. Okay, for 25, I can break 25 up into 5 times 5. Now I'm going to check here. If I multiply 5 times 3, I will get 15. And when I multiply this one with this one, I'll also get 15. And 15 plus 15 will give me 30. So I know this is the combination to go with. All I have to do is play around with the signs so that I get a positive 25 and I get a negative 30. So I can say that I can get positive 25 by having negative 5 and negative 5. That will give me positive 25. And I will also get negative 15 here and negative 15 here, which will give me, this will be negative 15x. This one will be negative 15x. That will give me a total of negative 30x. So this combination works. And here is your final answer. That would be 2x times 3x minus 5 times 3x minus 5. And if you want, you could write this as 2x times 3x minus 5 squared, because you have this factor twice. So you can add the exponents. The bases are equal, the exponents you can add. Okay? And there you have it. This option, we're not even going to try because we know this one was the one that worked. I hope you understood. I'm going to do another video with another example on factoring using grouping.